Screen is visible.
Yes, ma'am.
Yes. So we were discussing about the different sorting algorithms: selection sort, insertion sort, merge sort, quick sort, bubble sort. Can you able to see the various? Can you able to see the merge sort is here, quick sort is here, bubble sort is given. Okay. So if you the input is almost same. Same input is given to merge sort, quick sort. Here merge sort and quick sort uses divide and conquer technique, and we have bubble sort. I think it's selection sort and insertion sort. If you run the algorithms, you can now you can observe the merge sort and quick sort. These two algorithms are using divide and conquer approach. When you run in merge sort, how it is functioning means it is taking the merging, then sorting, divide, conquer, and combine. Divide. So compared to merge sort and if you compare these two algorithms, merge sort and quick sort, say the quick sort is almost finished, but for the same input, merge sort is still working. If you take the insertion sort and bubble sort, it is still functioning. Even the merge sort also still functioning. I think you got the idea how it is, how quickly it functions for the same given input. In yesterday's class also I shown you the comparative analysis of merge sort, quick sort, bubble sort, insertion sort, and selection sort, how they are functioning with respect to the different inputs. The screen is visible now. Yesterday we saw, for the given same input, how the insertion sort, selection sort, bubble sort, merge sort, quick sort is functioning. If the input is random, if the given input is in partially sorted, if the given input is in reverse total, if it is in a descending order, we need to sort in ascending order. Say if you take the quick sort, now you will see how the quick sort is functioning. The quick sort is compared to all other methods. Say if you take merge sort, it merge, sort, then combine. Here also, if the given quick sort, if the given input is in totally reverse order, in that case also, the quick sort takes very less time compared to the merge and merge sort. If you take the merge sort, if the given input is in reverse order, it takes more iterations as well as it takes more swapping. Hope you got some idea how the sorting works. Have you tried? Yesterday we discussed merge sort. Have you tried the program? Have you run the program in the compiler? The screen is visible now.
Yes, ma'am.
the second class itself, I told you people execute the program and show me the answer. Switch on your video and show me the answer. How many of you did? How many of you tried few programs? Okay, we were discussing about the divide and conquer technique, and then we saw the quick sort and merge sort. Now we'll see how the quick sort programming is. We discussed this selection sort. This is a bubble sort, and this is a selection sort. Then we discussed. Now we'll see how the pseudocode is implemented as a C++ program. To take the quicksort, it is a divide and conquer algorithm. It uses quicksort first divides the large array into two smaller subarrays. The low elements and the high elements. Quicksort can then recursively sort the subarrays. What we will do? Quicksort first divides the large given array elements into two smaller subarrays. So the given n elements is divided into n by 2, n by 2, two subarrays. The first n by 2 is called lower elements, and the other one is called the high elements, or we can say the first of and second of. Quicksort can then recursively sorts the n by 2 elements. After dividing the given n elements into n by 2, sort the n by 2 elements, then sort the n by 2 elements, then merge the n by 2 elements to get the complete sorted list. And if you take the algorithmic steps of quicksort, it is very simple and easy. We have only three steps. The first step is pick an element called the pivot from the array. So we need to find out an quicksort means we need to find out an pivot element. Okay, where P is in the quicksort, where P is called pivot element. Your step two is partition. Partitioning is the second step. Okay, what is partitioning means? With respect to the pivot element, we have to partition the given n elements into two of. If you take binary sort or binary search, we will find out the midpoint. With respect to the midpoint, we will divide the given array into two sub of. But in case of quick sort, we won't directly go with the midpoint. We will take an pivot element. With respect to the pivot element, the elements which are less than the pivot element will come to the left hand side. The elements which are greater than the pivot element will go to the right hand side. We'll take the pivot element, and with by taking the pivot element as an key value, the elements which are less than the pivot will come to the left hand side, and the elements which are go to the greater than or equal to pivot element will go to the right hand side. In that way, the array is sorted. That's what the quick sort is very fast compared to the remaining algorithmic techniques. So reorder the array so that all the elements within the values less than the pivot come before the pivot. Okay, the elements which are greater than the pivot will, and the elements which are, while all the elements with values greater than the pivot come after it. So that is the logic. So we will take one person. The person, the people who are the smaller looks very small or high based on height. So when the people are standing in schools for prayer in an order, the playground, if they want to make the students to stand according to their height, so a person will be standing. The those who are greater than that person will stand backside. Those who are smaller than that particular person will stand before them. So that is the general procedure followed in prayer halls or in the playground meetings. After this partitioning, the pivot is the final position. So with respect to the pivot element only, we are sorting the elements, the elements which are less than pivot, the elements which are greater than pivot. This is called the partitioning operation. So in the quick sort, we'll find out and we have a partitioning function, and the partitioning happens based on the pivot element. The pivot element is the key value. With respect to the pivot element, the elements which are less than pivot will come before that. The elements which are greater than or equal to pivot will come after the pivot element. If you take the step 3, recursively apply the above steps to the subarray of elements within smaller values and separately to the subarrays of the elements which are greater than greater values. So the elements which are greater than the subarray will be placed one side. The elements which are greater than, smaller than subarray will be placed another side. So any doubt in the logic, quicksort pseudocode also very simple and easy. And quicksort the pseudocode is same as merge sort pseudocode. And if you take the algorithmic steps also very simple and easy to understand. We have only 3 steps. Step 1 is find out the pivot element, and with respect to the pivot element, partition the given n elements into n by 2 elements. After making the elements n by 2 with respect to pivot, the elements which are less than pivot will come before that, and the elements which are greater than pivot will come after that. In that way, we are calling the quicksort 2 times, and we are sorting the subarray elements. And recursively repeat the process of partitioning as well as quicksort process for n by 2 elements until all the elements are sorted. Any doubt in this? What is quicksort? What is the pseudocode? What are the steps we are following? Okay, all of you take your laptop, try this program, and show me the answer. Quicksort algorithm. Tanvi Chaudhary, switch on your video. Show me the laptop. Avitra, am I audible or not? The screen is visible.
Yes, ma'am.
Okay, what is your idea, you people? The previous last week also I told you, you people switch on, run and execute the program and show me. Nobody responded. Whether you people are understanding the algorithm, pseudocode, program. How many of you tried the program? How many of you executed the program? You wrote in the observation or not? Simply will today itself we can complete the unit 2 portion. Whether you did the respective programs, you understood the logic, read the topics, PPTs. Okay, if you take the quicksort program, the program is in C or C++.
C++, ma'am.
So we are including because it is a simple C++ program without using much object-oriented programming concepts. Only we are using the main program and the subprogram. We are including the header file for input output stream, hash include IO stream, then using namespace std. So we have the function. Our function name is quicksort. We are passing the int x, where x is the array, and we are passing two more integer variables, int lb, int ub, where lb is the lower boundary and ub is the upper boundary. It means we are passing the array and the lower boundary, lower index, the starting index of the array, and the final size of the array, last index, a of the say x of 0 to x of n. LB means lower boundary, UB means upper boundary. Because we need the LB and UB to find out the pivot element. So if it is quick sort, we will use the keywords pivot, lower boundary, upper boundary, and the array. Because it is sorting, only the array. If it is normal, normal sorting methods like selection sort, insertion sort, selection sort, bubble sort, we'll use the array and size of the array. But here we are taking the upper boundary as well as lower boundary. Within the function quick sort, the function return type is void, so it won't return because the function is return type is void type, so it won't return anything back to the main program. And we have our main program here. Within the main program int main, so the return type of the main program is integer type, so it will return 0. The main program starts here, ends here. Within the main program, int n is the size of the array, I is the index variable. It is used for loop. Two integer variables, int list of 30, where list is the array of 30 elements. All are of integer type. So the variables are declared. Then we are using the input statement cout, enter the number of elements. Then we are reading the cin, how many numbers, whether you want the size of the array is 30. You can give, you can sort 30 numbers or you can sort 10 numbers or 5 numbers. Then cout, enter the n numbers, whatever you gave. Okay, cout, enter the number of elements. You are getting the number of elements. Then enter the n numbers using for loop. Cin all the array elements. For I equal to 0, I less than n, I plus plus. Cin read all the 10 numbers or 20 numbers. Then we are calling the function quick sort of. The array is paused as it is, and the first starting index is 0, and the number of elements is 0 to n minus 1. The function quick sort is called. Okay, we are calling the function quick sort. When we call the quick sort, the control will transfer to the quick sort function, and the function is return type is void, and it takes the array lower boundary and upper boundary. So in the function call main program, we are passing the a list of all the array is passed, and the lower boundary is 0, the upper boundary is n minus 1. So 0 to n minus 1, all the n numbers are given to the function quick sort. Using the function quick sort, we are sorting the numbers. So within the quick sort, what we are doing, within the function starts here and the function ends here. Within the function, we are declaring the variables. Int down, down is the lower boundary, up is the upper boundary, pivot is the p variable, pivot element. With respect to the pivot only, we are going to sort the numbers, and the temporary variable t. So in general, we will use the temporary variable temp or t while swapping. We'll put the, if you want to swap the given two numbers, we'll first number will be sent to the swap temporary. Then the content of A, B is, if you want to swap the content of A to B, what we will do, we will use a temporary variable. The content of A is transferred to temp. A is transferred to temp. Then B is transferred to A. The temp is transferred to A. So for the swapping purpose, we are using a temporary variable, pivot variable, lower boundary and upper boundary. Then we are checking if LB is less than UB, where LB and LB is 0, UB is the n minus 1. So 0 less than n minus 1, the condition is satisfied. It means there are some numbers in the array. If there are some numbers in the array, then only we can sort the numbers. Otherwise, we cannot sort. If no elements are, say you are if you are giving the input as 0, if there are 0 numbers in the array, how can we sort? If there are only one number in the array, we cannot sort. So at least if there are two numbers, then only we can sort. The two quick sort. Then we will check the condition down equal to lower boundary, up is upper boundary. We are using the variables like lower boundary, upper boundary. They are the formal arguments. And the local internal variables down, up. Down is equivalent to lower boundary, up is equivalent to upper boundary. And pivot is the pivot element. So the lower boundary is assigned to down, upper boundary is assigned to up, and the down is assigned to pivot. So the local variables are assigned to the arguments. Then we are checking the condition while the down is small and upper is higher. It means the zeroth index is less than the size of the array, while x of down less than or equal to x of pivot. We are taking the pivot element. Based on the pivot element only, we are going to sort the numbers. So if the pivot element is greater and the down element is uh, x of down, means the array x x of 0 is less than or equal to x of the pivot element, and down is 0 is less than n minus 1, where down is the lower boundary, it is 0, ub is the upper boundary, it is the size of the array. So when these two conditions, x of down is less than or equal to x of pivot and down is less than upper boundary, when these two conditions are satisfied, then what we will do, we will increment the down plus plus. So the upper bound down zeroth index is incremented to plus I 0 plus plus, it becomes 1. While x of up is greater than x of pivot, then increment the upper bound. So it means we are taking the first number that is compared with the pivot element, and the first number is small and the pivot element is greater, then the small number is kept left side of the pivot. If the number is greater than the pivot, then it will be sent after the pivot. With respect to the pivot element, we are sorting the numbers. Left side of the pivot should be smaller numbers, smaller than the pivot numbers, and the right side of the numbers should be greater than the pivot numbers, and the numbers will be ordered as per the value. If the condition is not satisfied, up is greater and pivot is small, then up is decremented, so that the down less than up, down is small and up is high. Then we are swapping the content of down to temp, x to down, up to down, and temp to up. Down to temporary, up to down, and temporary to up. It means the content of down is down and up is swapped. When the condition satisfies, down is smaller and up is greater. So the process is repeated until, so we have a while loop, two while loops. This is one while loop, and we have one more while loop. And we have one more three while conditions. This condition, this condition, this condition. When all these conditions are true, then only the swapping happens. Else, the pivot is put to temp, and up is put to pivot, and temp is put to pi. If these three while conditions are true, then the content of down is swapped with the up. If these two conditions are true, but this condition is false, means the pivot content is swapped with the up element. Again, we are calling the same process quick sort of lower boundary to upper boundary and upper boundary plus 1 to upper boundary, that is n by 2 and n by 2. We are calling the same recursive quick sort two times. So any doubt with respect to the quick sort? So in the quick sort algorithm, we are sorting the given numbers with respect to the pivot number. We need to take the pivot number, then we have to start sorting the numbers which are greater than pivot and the numbers which are less than pivot. Two subarrays. Any doubt? Once the quick sort is completed, then see out after sorting for I equal to 0, I less than n, I plus plus. The sorted array of numbers will be displayed. Any doubt in quick sort? Shall we move to the next topic?
Yes, ma'am.
So, what is our next topic? Have you gone through the syllabus? Have you downloaded the syllabus from the VTop? What is your subject? What is your subject code?
Yes, 2002.
CSC 2002. Okay. So, we were discussing about two types of algorithms, brute force approach and the divide and conquer approach. Using brute force approach, we discussed the general algorithm. Then we discussed insertion sort, selection sort, quick sort, bubble sort methods. Then we discussed divide and conquer approach in detail. What is the general approach? Then how that the divide and conquer approach is used to sort the elements using quick sort, merge sort, and binary search. Binary search also we already discussed. In the unit 1 PPT itself, it's there. So any doubt with respect to the unit 2 topics? Shall we proceed with the next topic?
Yes, ma'am.
Okay, what is our next topic?
Searching,
What is our next topic?
searching,
What is our next topic? Refer the syllabus.
binary search. Binary search.
Binary search. So we didn't discuss the binary search so far. We discussed binary search or not? The screen is visible. Screen is visible.
Yes, sir.
Binary search. So we already discussed. So far we were discussing the quick sort, merge sort, and the selection sort, bubble sort, and insertion sort. So these three techniques we are using brute force approach. For quick sort and merge sort, we are using divide and conquer approach. So if you, from this table, you can easily understand. We already discussed in unit 1 to take the best case, average case, and worst case, time complexity and space complexity. Quick sort needs for n numbers, order of n log n in best case, average case, in worst case. If the given list is in reverse order, we need order of n square. And the space complexity for quick sort is log n. But if you take merge sort, for n numbers, it needs order of n space complexity. We need n spaces to store all the n numbers. And in merge sort, best case, average case, and worst case, all cases, it needs n log n multiplied by log n. If you take selection sort, bubble sort, and insertion sort using brute force approach, these methods follow brute force approach only. In best case, average case, and worst case, selection sort needs big O of n square, n square, n square, and complexity, space complexity is order of 1, big O of 1. And if you take the bubble sort, best case, average case, and worst case, uh, it needs best case means it's already sorted. Then it anyhow we need to go through n comparisons, and No swapping, but comparison has to be done. So we need order of n. In average case, partially sorted, order of n square. Worst case, reversely sorted. It's in the reverse order. We need to reverse it back. So we need order of n square. In insertion sort, if it is already sorted, then order of n. Partially sorted and reverse sorted, order of n square. Then we discussed the unit 1 itself, binary search. Binary search technique we discussed to explain the concept, because I told you to write the second program in your observation, na? Linear search and binary search. So we taken as an example, we discussed along with the unit 1 topic itself, end of the topic. So we taken the linear search and binary search, how it is functioning. Then we compared the with respect to the number of elements and the time. Number of elements in the x-axis and time in the y-axis. We taken the efficiency. So with respect to binary search, after up to 5 numbers, the efficiency it's increasing. After 5 numbers, even if you give 20 numbers also, the time is almost constant. But linear search, the time complexity increases with respect to the number of inputs. If you are giving 15 inputs, it needs 15 minutes to execute the program. If you are giving only 5 numbers or 4 numbers, we need 3 seconds, 3 minutes. But binary search with 4 numbers, it needs only three minutes. If you give 5 numbers, it needs 5 numbers, 6 number, 8 number, or if the input size is 15 also, it takes the same 3 minutes. Then we compared the variant of linear search and binary search algorithms. Then we discussed in detail what is linear search, what is the time complexity, space complexity, what is the definition, what is the pseudocode, what is the logic behind linear search, algorithmic steps, pseudocode. Then we saw the difference between what is linear and binary. Because linear we are using brute force approach, binary search we are using a divide and conquer approach. Then we discussed what is binary search. It is more efficient algorithm but requires list of required list to be sorted. It repeatedly divides the search interval in half to locate the target element. So what is the time complexity, space complexity, implementation, algorithmic steps. So the algorithmic step is in binary search, add the lower boundary plus with higher boundary, divide by 2, you'll get the midpoint. With respect to the midpoint, divide and conquer. So this is the pseudocode. Then we discussed how it is functioning. From this diagram, we can easily understand. I think we explained this slide more than 4 times, 3 times. This may be the 4th time. So any doubt in this diagram? Any doubt in this picture?
No,
So,
ma'am.
so we are going to search for the given number 23 from the given list of 10 numbers using binary search algorithm. So the array index starts from 0 to 9. Total 10 numbers are there. Our searching element is 23. We have to check whether the searching element 23 is present in the given list of numbers or not. For binary search, the given list should be in sorted form. Then only we can divide and conclude. If it is in unsorted form, we have to sort first, then we have to divide. Then only we can go for searching. So our searching element is 23. As per the logic, we are taking the lower bound, upper bound. Lower bound is 0, upper bound is 9. We are finding out the midpoint. The lower bound is 0 plus 9, 9 divided by 2, 9 by 2, 4.5. So we are taking the midpoint as 4. As per the binary search, the searching element should be directly compared with the midpoint, not with the first number, second number, or last number. The searching element should be compared. First comparison will happen after finding out the midpoint. Compare the searching element with the midpoint. Now the searching element is greater and midpoint is lower. It is less value. Then, as per the logic, the searching element will be after the because the midpoint is 16 and the searching element is 23. 23 will be definitely after the 16. So we are discarding these numbers. So it is marked as dark. So we are changing the boundary now. We are taking the next number, mid plus 1 as the lower boundary. Now the lower boundary is changed to mid plus 1, 5. Upper boundary is taken as 9. Add the lower boundary with the upper boundary. Now 5 plus 9, we are getting 14. 14 divided by 2, we are getting 7. 7 is your midpoint. For the given, for the new list of lower boundary to upper boundary, the midpoint is 7. Now our second comparison happens. The searching element 23 is compared with the midpoint. Always we will compare in binary search. The searching element will be always compared with the midpoint, not with any other number. Now the midpoint is compared with the searching element. Our searching element is 23, midpoint is 57. Definitely 23 is lesser than 56. So we are discarding this array. We are taking only mid minus 1. The boundary is now changed. Now the lower boundary is 4, 5 and upper boundary is mid plus 1, mid minus 1, 6. So we will discard this portion. This is marked as dark. Only we will take this particular list. Now we need to find out the midpoint. Lower is boundary is 5, upper boundary is 6. 5 plus 6, 11. 11 by 2. 11 by 2, 2 is 5. Now we are taking the midpoint as 5. The third comparison happens with 23 is compared with the fifth element, midpoint. Now the searching element is matching with the midpoint. The element is found. And the position of the element is 5. We are finding the midpoint, comparing with the midpoint. Only 3 comparisons happens. So within 3 comparisons, we are finding our searching element. If it is linear search, we need to compare the searching element with all the 9 numbers. If the number is in the last position, then only we can able to find out. We need 9 comparisons. But in case of binary search, we need only 3 comparisons and 3 midpoint calculation. So that is the why, because here we are using divide and conquer. Dividing the midpoint, dividing in the midpoint, dividing the midpoint, then we are comparing. So any doubt in the binary search algorithm?
No, ma'am.
So this is the algorithm. This is the pseudocode, and the same pseudocode if you implement, you will get the program also. Already we discussed the differences between binary and linear. So if you take the corresponding C++ program, so this is our corresponding. The screen is visible.
Yes, ma'am. The binary search algorithm we already discussed. So this is the first program we discussed using binary search and linear search. So this is linear search program using recursive, non-recursive. Then we discussed the binary search. So the logic is given, pseudocode is given, finding out the midpoint. Then so we have the main program, index variables, list of 25, read the array elements, call the binary search. And in the binary search, we are taking the mid position and position as -1. We will check whether the lower boundary is lesser, higher boundary is higher. It means there are some elements in the array. Find out the mid search. I will take the attendance from the Zoom recordings. So very simple logic.